everyone, welcome to my channel. Today I will show you how to search target for drug treatment. So which kind of target you should use for treating a disease. For example, today I will check to see target for treating cancer. For treating cancer, then screen compound to inhibit the target, the protein. So most compounds we can search from a library we call the PubChem. So we can go to scope search the PubChem website. You can choose the PubChem. At the beginning step, we can search a target. Today, we can use PARP1, which is most used for clinically used for treat breast cancer. In order to find compounds for inhibition PRP, we can choose PRP gene here as a target to search all related compounds, chemicals. After chemical found screened, then we can using Python and progress, something like RDKit, to dissect compound feature to help design the new compounds. So at the beginning, we need to know the protein. Here we found the target protein, PRP, is from human. It's called poly-ADP ribosome polymerase. This gene protein regulates DNA damage repair. If give compound inhibitor inhibit PRP activity, this protein will stay on damaged single DNA or double-stranded DNA. Then the DNA cannot repair, cell died. Purpose it can kill the cancer cells. Okay, let's click target PRP1, which shown the description here. It depends on DNA involved important cellular process. This is described here, but we need to know related chemicals here. So once we click chemical, you see that total almost 7,087 items involved. Here is structure. Here the activity is activity type can use different IC50 or Ki inhibition, and the active value is micromolars. Compound is any number here. So if when you get the list here, you can download by here. Click download all chemicals. So you can use CSV, JSON, and XML. But for us, we using Pandas, Python, to handle that clean data. So we use CSV file. Click, you see the file could be downloaded here. The data download can open that to see problem. PubMed. Okay, this file open. In CSV, you can check what it looks like. Here is a compound. It's called ID, and we just care about the target, ID number, and the value. For example, this value. So we care about the value. Also care about gene ID, activity, and name. I reassign the name of each column. Actually, we most use the compound ID is each column, and activity value, and activity for like this for category. So this data need to be cleaned. So we choose some columns for folder process. So here is name, chemical name, and and function assay. This name here. Be careful. At this part we don't have specifiers. So this part we only search related compounds for inhibiting this target, for activity, for name. After data cleaning of everything, for example, we need to remove something non-value, no-value columns, some compounds, duplicates. So after our clean, then we'll find this compound SMILE files. If we don't have SMILE files, so we cannot extract structures, common structures, and features for further design chemicals. Okay, this part is done for target and relate chemical compounds. Okay, next step we need to clean data. Clean data I used Python Pandas. So now I'm starting my Python Python software use Anaconda. So I think you guys already installed. So we will continue for next step. However, if you don't have the Python Jupyter notebook, Jupyter level installed, we can next time we can go to next video to show you how to install Anaconda Python package. Okay, when you open the Jupyter Lab, you can begin to process your data. Before processing data, we need to localize the food data in where is that. So we will save our data in specific fold. So at the beginning step, you should use import OS to set your working directory as OS change direction. This is fold my data used, my project data used here. So my document has a folder is drug discovery specific for breast cancer, has different projects, but I give a PLRP or different targets. So I temporarily locate the data here. So this when you open this a little trick, need to use R for entering this part, this fold, because otherwise you need to change the pathway slash like this. For this is the most easy way to enter location. For example, this is my data fold. I copy as a path. Then you can paste here. That is whole pathway. So only thing you need to do is put R in front of that, so you can open the file or store data here. So this is the first step. Need to localize your fold so when it works, because we need to use pandas and NumPy to handle data, clean data. So you need dependency, pandas and NumPy. Input pandas as PD, NumPy as NP. Then we use pandas reader SOA file function. To open the file, you just download search target protein. So its genes 142, it is a PLRP1 inhibitor, PLRP1 protein. So that you download from PubChem. So when you open that, the original file from PubMed, you can see everything here is total 7,087 rows is chemicals, and 27 columns with different names for base ID, compound ID, target name, compound name. So that is raw data you download from PubChem. However, this data is not can be useful because not clear. So a lot of things information we don't need. So for you can check the data frame with shape shape. You see total is rows and columns. If you want to see information in details, you can see every column here and the data type and the rows name. The index here, total is 27 columns. So we need to pick up what we need. We need to pick up now. We pick up the compound ID number, compound name, activity value, activity name, and target name. That part with selection. So we see using selection to pick up the several columns here. So we need compound ID number, compound name, target name, and active values. So several important parameters we pick up now. So we're running the update BF1, running DF1, update DF1 data frame 1 to update them. When update, you see the name, compound, activity value, everything was kept. However, we can further continue to check something not right in the data. If you use activity.unique to check whether something value is unique, we found in activity is something unspecified, inactive, inconclusive activity. It's a lot that messed up. We not useful. That cannot be used for our drug design. This is raw data. I like to store somewhere. Later on, I can delete that. But I want to keep step by step, keep every raw data here. So finally finished, we can keep only final data. But at the beginning, given the transition status, I keep in case something wrong. So I store the inhibitor at PubChem inhibitor software using two CSV to store this file. Index false. Index false, it means we don't want to keep original index. We just want to see whole this data files. Even later we can reset index, but we just want to know we want to keep compound ID, activity name, target name, something like that. So again, we open the stored file and as df2. The df2 is here like this. We see that it's still 7871 rows, compounds, and 6 columns we choose. For drug principle, you most use several parameters to check the compound functions, activities. So IC50 is the most useful. Someone use IC90, but this is very common for drug design. Drug use the concept IC50. Someone maybe use KI, but you only choose one category because you need to know each compound can be compared based on one parameter. So you choose IC50, most of data like that. Good. Otherwise, if you don't have enough compounds for analysis, you can choose something other part, some KR, something other part to relate back to this. But because here we have tons of IC50, so we pick up IC50 for further next step processing. So here is df2 data frame 2, choose activity columns, and the value is s50. So we pick up the value, so give update of this. So df2 update. Update the D data frame, all s50, all column was picked up here. So I keep the saved data as raw data in case something wrong. My personally like this. So I continue for open again, and IC50 value are kept there. So we have 4,530 values chemical kept. Let's check the data what look like. And this data from activity value here, still some non-value here. So we don't need that more. It's non-value, so no value. So we need to clean that. So we need to drop the non-value NA. So use function to run it here. See, and drops non-value. After dropping, active value all here is micromolar. It's always a micromolar value. So that is important for us for drug design because we need to build a machine model for analysis. So active value we either can categorize with some value is activity or non-activity, or I can change it to PIS50, which can be used for machine learning model for regression. So that's important. Active value are cleaned. So when you use the column actually unique dot function method to check see our value is value number. Then we can see activity name also is IC50. So the data clean looks clean. However, in activity column here, still something is active and specified inactive. This part is usually we need to rearrange them because we want to see some inhibitors, maybe at the nanomolar it is active, some value is non-active, so we need to reassign the value. But I keep this raw data original here because give a concept what's original data for judge. This drug is active or non-active. Because different experiment, different protocol has something different here. Give us a judgment. Depends which range for compound. The literature how to judge this compound is refers active or non-active. But in your design protocol, you can base on active value to reassign activity to make data balanced in activity or non-activity. So for involve whole related compound, starting compound you put together, you get it so that you can reassign some values is active, some doesn't inactive. When you compound two structure, you can design the better compounds for targeting this protein. This column only for your suggest for your opinion, for your judgment from the literature, what the reality is. I keep this for to final data. That's another like this. So after this, we save data is activity clean. activity not clean, so we keep the keep activity here. So we open again, see all LC50, all value here. Activity line is something we need uh, uh, rewrite again, depends on value, but now I keep that. So in order to keep data is clean, I need to check the compound name whether it's still unique. So after checking, the target name is compound name, target name or is unique, is for human. I don't want to involve some right mouse data inside. Species different, has different protein PDB, 3D structure. When doing some protein docking, dynamicing, different species have different reactor. So you compound maybe affect human, not affect rice or mouse or something like that. So we need to ensure the target or from human. I don't want to see something maybe a mouse rat involved. So we are in order for the complete sure my data is clean, no duplicates. I continue running for the data frame job duplicates. After dropping, you see we have 4,085 compounds left. Before dropping, looks like 4,431 rows compounds. So it suggests some value or some compound is duplicate. So after dropping duplicates, we can keep the after dropping in the transition status. So after that, I still want to say after check target name already checked, but I also say compound name. Compound name check say a drop duplicate. After dropping, the compound is not duplicate. It's still say 4,085. Before dropping, so compound no duplicates. So target is no duplicates, and everything looks clean. So we keep the data to final. That is final. Final here is compound ID is clean, compound name, activity value, active name, and target name. So it's final for chemicals information, but the thing here is no any smart files. So that is very important things we need to know. Otherwise, we don't know how to dissect the chemical structure and the chemical feature parts. And we don't have ability to design new compounds against target. So next step, we need to download smart files. So for over 1,000 chemicals, so we need one simple way to download smart file. And we don't need to use some software, something otherwise to edit it. So one is simple way is you can upload your compound ID to PubChem. When you upload the compound ID number to PubChem, then you will download all the smart files to smart file together. This is the simple way. So okay, let's to our PRP1 inhibitor final file to download to upload the upload okay here this is our final. When I open the final, you see compound already clean. and compound name, activity value, and target name. So you can see beautiful company, give it clean data. For compound search, you can click here to copy, upload to your PubMed. PubMed here. We can go to PubChem here. Up ID list. Okay, let's go to choose file. We can use Notepad++. I usually use Part for writing language, Python or R language. I like this one for our routine task. Okay, that's compound ID for here, Notepad. Be careful, you need delete this one. That's website doesn't know that. And save as here, save as compound ID number. So I use this here before. So that works. So okay, I can compound ID again. POUND compound. And text file. That's okay. Let's close that. So when you choose file from here, you see my documents. See I use my press cancel. After choose file, upload your compound, which show you success. So after the reading of files, the ID number is a success. You can search with published. After searching, you upload 4 storage 85 with compounds. Then you get feedback for each compound ID and molecular weight, name, and smiles. And also have each key value. So different people have different requirements. So you can choose everything you want. But for us, smile is very important to us, to me. So here, each compound, it got everything almost done for smiles. So smile. So PubChem. Where's John Power? You don't anything to modify, change that. If you download this, you can download this data. So for this one, this data still need cleaning. So after you download this, you can clean that. For some specific chemical, you're doing some docking, molecular docking, or something like that, or drug editing, you can use SDF, 2D or 3D. But at this step now, we need CS file. After download, you can open that. This file say compound ID here, compound name here. Looks a lot of chemical here. is this compound ID. It is your required search. We need to know smart file. We want to see smart file for so download. Next, we want to clean all the data, each chemical with smart files. Okay, let's open that. Use pandas. Continue. So continue. This is file. So we continue use PRPY inhibit smart file. Just download for that. Then we want to see want to run that file. Have 3,600 chemicals download with the smiles. This is compound ID number, compound name. I have given you a molecular weight, complexity, and hydrogen bond donor, acceptor, something like that. So have tons of information, but we need to keep up we need. So before keeping something, we need to check overall picture looks like. Here is using info function to check what looks like the whole data frame. We have compound ID, compound name, and complexity, polar area, hydrogen bond donor, and smiles. We need smiles. That's here. We choose compound ID name connect smiles for this new download file. After that, this file is the compound ID, compound name, and kinetic smiles here is collect. So we can save the file to inhibited smile files. Index false. We don't want to keep the original index. Otherwise, when you open again, that's new index. as a new column. So open again, say as df6 to df6. We have smile file, but we want to see combine the previous data frame with this data frame together. So we not only have ID number, compound name, kinetic smile file, but we also have activity number and activity name activity. So we can combine together. Then we get then we can follow the process. So let's back to the original data, df6. That's the first data frame we cleaned here. Now we need to drop. Check again. I found something still not clean in compound ID. Not clean, so we need to drop again to check the data back to 36,000. That's reasonable. We smile file. We will have a smile file, say 6,000, 36,600. So we first data from now kept of 3600. So compound ID actually is duplicate. So we clean that job. So we update the data frame. Job not found job name, compound name, compound name. Okay. DF6 we don't have component. Yes. Job we don't need a component. Yes. So we deleted that. So for DF6 we don't have a component for that. We don't need job that. So here I will go combined smell file merge with DF6. Compound ID. Okay, that's important for combine together. We need based on compound ID number to merge two data frames. So this merge is very important. Otherwise, we get some errors. So we need to write code like df small file column merge function to merge with df6 compound ID. This is compound ID, df6 compound ID, and df smiles has compound ID here like this. So they are need to keep them similar. And merge with compound ID columns and the method inner. So each x will x will be merged compared the same. So after combine together, so according to combine number combine together, 3600 rows combined with together with compound name, connect smart, value active, and target name. So that's all part of work done for two data from combined. So this combined we can save as transition steps. After combining, read again, open again, is exactly matched. Chemical numbers and column names. That we need that. So we can check some value like kinetic smiles. So you see, very beautiful. In order to check whether still something empty or not, something like that, weird thing. So we need to continue to process. This is defined as a combined file. We use if we give a column name is non-value. All of them checked all column is non-value, then we need job. If something is one column, one value is empty or contain non-number values, that's a job. Otherwise, we print is not empty value. So we click that. So the connect smells column is not empty. Okay, we check again. Column name is active value. Same the function check. So looks everything is not empty. It's clean. It's data. It's good. So everything we checked it is smart files, active value, and the compound ID are clean. Good. So that is for data cleaning. So for after finish data cleaning, we can keep this final PRP target protein chemical list for the process. So we can add structure for this, or can extract something like fetch protein, RGKit fingerprinters, something like that. We can extract that. Or can based on this, or can use build a machine learning model can predict your new design compound activity. These are based on this data. If you don't have this clean data, this compounds list, you don't have a chance to finish for design compound, to predict design compound activity, for design for new compound, the design compound for docking, dynamics assay, etc. Okay, next time I will show you how to check how the compound be designed and doing some binding with target to see whether the uh, binding effect activity is increased or decreased. Depends target. So in cancer, in some disease development, the protein usually happens something like a post-methylation or mutation, something like that. The activity will change. So if the protein modified, the activity lost, the existing compound cannot bind this, especially for patients like cancer. Is the protein gene mutated very fast, always affect the protein structure, PDB structure. So we need a new compound to check whether the can treat the disease during the progressing. Okay, next time I will show that.